discussed equivalent decimals, like decimals and unlike decimals, isn't it? Yes. Today we are going to discuss about comparing decimals and ordering decimals. Okay. Before that, just recall what we have discussed in our previous session. Understand? Yes. In our previous session, we discussed about equivalent decimals. Equivalent decimals, now you know how to do. For example, 3.5, you know how to write the equivalent decimal. You can write it 3.50, 3.500. That is, you have to add the decimal place zeros, isn't it? Yes. For example, 74.31. What is the equivalent decimal? Equivalent decimal is 74.310. Then 74.3100. These decimals are equivalent decimals, isn't it? Next one is like decimal and unlike decimal. See, if I am giving two decimal means you can identify that it is like decimal or unlike decimals, isn't it? See the example: 4.73, 2.523. These two decimals are like or unlike decimal. These two decimals are unlike decimal. How we know? After the decimal places, here only two numbers, isn't it? Two decimal places. Here, after the decimal, here three numbers. So these two decimals are unlike decimals, isn't it? These two decimals are unlike decimal. For example, 5.31, 7.42. So these two decimals are like or unlike? These two decimals are like decimals. See, after decimal, two numbers here, here after decimal, two numbers. So these two decimals are like decimal. These two decimals are unlike decimal. These two decimals are like decimal, isn't it? So now you know equivalent decimal, like decimal. You know how to find the equivalent decimal, then like decimal and unlike decimal. Yes, now we are going to discuss about converting unlike decimals to like decimals. Now we are going to convert the unlike decimals to like decimal. Okay, unlike decimal, for example, 7.34. Here are the number 3.846. So these two decimals are like or unlike. Now you check, after the decimal place here two numbers, here three numbers. It is unlike decimal. Okay. Now we are going to convert it into like decimal. Like decimal means what? Decimal is same number, isn't it? Yes. See here, what we have to do? We have to add 1 0. That's all. Now you just check here. Here after decimal three numbers 340. Now here 3.846. After decimal here we can see three places, right? Three place values. That is 10th place, 100th place, 1000th place. Here also 10th place, 100th place, 1000th place. Isn't it? Next number, see 18.41. Here 25.3. Here 18.41, here 25.3. So after decimal, here two numbers, right? Here after decimal only number. So where we don't need to put 0? Where we need to put here. Now it is like decimals. After decimal it is same. Here 2, here also 2. So these two decimals are now like decimals. Understand? See the example: convert 7.6, 9.53 and 6.23 to like decimal. Now these decimals are like or unlike decimal. Here 7.6, then 9.543, here 6.23. Okay, so these decimals are unlike or like decimal? Unlike decimal. Here you can see after decimal only one number. Here after decimal 3 number. Here after decimal 2. So here highest is which one? That 543. After decimal 3 numbers are there. So we want to make it these two decimal. After that you have to make it 3 numbers. Okay. So you have to add 0. How many here? In the first decimal 7.6. How many zeros we want to add? We have to add 2 zeros. Okay. Then the last one 6.23. How many zeros we need to add? Only 1 0. Now you check these three decimals are like decimal. After the decimal you can see three numbers. So these decimals are like decimals. Do you understand now? One more example. Okay, that 56.4, 2.743, 5.61. So here we can see that these decimals are unlike not decimals. Now we are going to convert it to like decimals. Okay. Now first number, how many zeros after decimal? How many decimals we need? 3. Already one is there. So again, how many zeros we need to put? Only 2 zeros. So add 2 zeros. Here 3 decimal. Here how many zeros we need? Here already 2 numbers are there. 10th place and 100th place is there. Then 1000th place we need, right? So you have to put one more 0. Now these 3 decimals are like decimals. Isn't it? You can do the activity. Okay children? See the first question. Which of the following is a pair of like decimals? Now you know like decimal and unlike decimals. Isn't it? Yes. The first one. 21.1, 2.11, 1.2, 1.02, 7, 7.02, 0.51, 0.04. So here it is the pair of like decimals. Which one? After decimal you check here 1, here 2, here 2, here 2. Sorry, here 1, here 2 after decimal. So which is the correct option? Correct answer is after decimal you can see 0.51, 0.04. So after decimal 2 numbers are there. So this is the correct answer, isn't it? Yes. Second question, unlike decimals. Here you have to write that pair of unlike decimals. See here, this is like decimal, isn't it? 0.403, 1.777, 56.09, 56.9 only. So this is like or unlike? Unlike. This is unlike decimal. Now the third one. Pair of like decimals. The like decimals here after decimal 2 numbers, after decimal 3, here 1, here 2, here 3, here 2, here 3, here 3. So pair of like decimal is, this is the answer. Fourth question, which of the following is a pair of unlike? Here unlike decimal. Okay, unlike decimals are, this decimal is like decimal. Here unlike, because after decimal 1, here 2. So here this is the correct answer. Here which of the following is a pair of like decimal. Okay, like decimals. This is unlike decimal, isn't it? This is also unlike decimal. This is like decimal with 30.009 and 30.900. It's like decimal. Next, which one of the following is a pair of unlike? Unlike decimals, find out. This is like decimal. This is also like decimal. Like decimal. Here after decimal you see here 4 numbers, right? 1 tenth, 100, 1000, then 10,000. Then here 10th, 100, 1000 only. So unlike this is the decimal. Here like decimals. Like decimals, first one is like decimal, isn't it? 0.70, 0.13, like decimal. Then here pair of unlike decimal. The first one is like decimal. This is also like decimal. This is also like decimal, isn't it? Then this is unlike decimal. So now do you know how to find that unlike decimal and like decimal? So now we are going to discuss about comparing decimals and ordering decimals. Comparing decimal means what? You have to compare them, which is the greatest one and smallest one. So here we are using the symbol. Do you remember? Less than, greater than or equal. Right? Yes. Then ordering decimals. Ordering decimals means what? Ordering numbers already you studied, isn't it? That is ascending order and descending order, isn't it? So decimals you are finding the ascending order and descending order. Before that, please watch a video. After that, we will discuss ordering numbers and comparing numbers. Okay, children?
Sometimes sometimes they can be pretty confusing. I mean, what's the difference between a comma and a decimal point in a number? Why is that number bigger than that number? Why do decimals even exist? What does it all mean? First of all, decimals are everywhere. They're used in every type of measurement. Distance, length, weight, capacity, volume, and money. The list goes on. So trust me, understanding decimals is going to make your life much easier. But what exactly is a decimal, I hear you ask? A decimal is a way of writing a number that is not whole. The numbers to the left of the decimal point are the whole numbers. While the numbers to the right of the decimal point are parts of a whole number, and these are the decimals. Decimal numbers fit in between whole numbers. It's common to get confused about the value of a decimal based on the amount of numbers we see in it. Often we think that if there are more digits in the number, then it must have a greater value. But that's not the case at all. The value of a decimal is determined by its place value, not by the number of digits it has. Let's have a look at some decimals. Do you think we can compare and order them from smallest to largest in value? How can we when they all look so different? When we have a collection of decimal numbers, the easiest way we can compare their value is by drawing up a table. Using this table, we can write down our decimal numbers and line up their place values. 1.4, 1.09, 1.006. Let's give it a go with these three decimal numbers. As you can see, the first decimal number has one place value to the right of the decimal point, while the second number has 2, and the third has 3. They look quite different, don't they? The first decimal number stops after its tenths place. This is because it doesn't have any more values in its decimal places. If there were more values after the tenths place, they would be represented by numbers. But since there aren't any, they are left blank. This is similar to the second decimal number, whose decimal number stops after its hundredths place. Let's fill in the blank place values in our table with zeros. This will make all our decimal numbers continue to 3 decimal places. There we go. Now that they all continue to 3 decimal places, it will be much easier to compare and order them from smallest to largest. When comparing decimals, always start with the whole numbers on the left side of the decimal point. Then move along the places to the right. Let's start with our ones. All 3 numbers have a value of 1 in their ones column, which means that so far they're equal. Let's move into the tenths. Our first number has 4 tenths, while the others have 0. This means that our first decimal number has the greatest value so far because it has 4 tenths. We can now label this as our greatest decimal. To find the order of values for the last 2 decimal numbers, we need to keep comparing. The next decimal number has a value in its hundredths column, while the other decimal doesn't. This number has 9 hundredths, which makes it greater in value. This means that this decimal is our second greatest number. This means that our last decimal number is the smallest in value, because it doesn't feature a value until its thousands column, which is smaller than tens and hundreds. Can you see how, even though the last decimal number had the most digits in it, it had the least value based on its place value? The key to successfully comparing and ordering decimals is to always look at the place value. Start with the whole numbers on the left side of the decimal point. Then work your way to the right through the rest of the place values. And even if a decimal number ends, you can substitute the blank value spaces with zeros to help you compare and order them. Soon you'll be solving decimal problems with no problem.
I think you got some idea about comparing decimals and ordering decimals, isn't it? Comparing decimals means, for example, 4.31, 3.74. So we have to compare these two decimals. We have to check in their whole number. Okay, whole number, here 4, here 3. So you can find it, which is the greatest number. Now here, which is the greatest number? 4.31 is the greatest number. Here 3.74. So the whole number is equal to, for example, 7.31, 7.48. Okay, 7.31, 7.48. Here these two decimal, now you compare which is the greatest one. First you have to compare the whole number. Here 7, here 7. See, equal. Then after the decimal, the 10th place you compare it. Here 3, here 4. Which is the greatest one? This is the greatest one. So here we have to use which is simple, less than. Understand? 7.31 less than 7.48. For example, the decimals are unlike. Here the decimals are like decimals, isn't it? For example, the decimals are unlike 7.34, 7.586. So first you have to convert it into like decimals. Okay, like decimals means here after decimal 2 numbers, here after decimal 3. Convert it 7.340, 7.586. Okay, 7.586. Now you compare here at the 10th place, the whole number same only, isn't it? So at the 10th place, here 3, here 5. So here easily you can find it. Which one is the greatest one? Here which one is the greatest one? This is the greatest value, isn't it? 7.586. So you have to use less than. Do you understand? You see next example. 6.351, 6.34. Okay. Here these two decimals are like or unlike decimal. Unlike decimal. So convert it into like decimals. Okay. 6.351. Here 6.34. What we have to put? 0, isn't it? 0. So now you see the whole number is equal. Then after the decimal, the 10th place, here 3, here also 3. Then you check the 100th place. 100th place, here 5, here 4. Which is the greatest value? This is the greatest number. Understand? Now you have to use less than or greater than. Greater than. 6.351 greater than 6.340. Now do you understand how to do decimals? First what we have to do, you have to compare the whole numbers. You have to convert the decimals. Like decimal, if it is unlike decimal means you have to convert it into like decimals. After that you have to compare the decimals. Okay, then which is the greatest value? You have to put the symbol, that is greater than or less than. So now you know that how to compare the decimals, isn't it? Comparing decimals now you know. So you can do it that ordering decimals also. If you know the comparing decimals means you can do that ordering also. So ordering means first you have to write in the ascending order means you have to write in the small number, then big number, then big number. You can write it like that, isn't it? Ascending order means small number to big number. Descending means what? Big number you have to write first. Now how to compare that, which is the greatest value, which is the slowest value, isn't it? So what you are going to do that? So you try to do that ordering decimals. Okay children? So your homework exercise 7.2. They are comparing decimals and ordering. Ordering means ascending order or descending order. So please try to complete your homework. Okay children, if you have any doubt, please contact me. Thank you.